Welcome to the fascinating world of garden railways. In the next half hour we'd like to bring you a little of the sights and sounds you can expect and show you how roundhouse models are designed and built. The title garden railway can actually apply to any size railway built in a garden, but we're only concerned here with a small group of scale and gauge combinations. To the newcomer, names like 16mm, G-scale and SM32 can all seem very confusing, so first of all let's sort out the nomenclature for our section of the model railway hobby. Let's get it clear from the start that all the models in our group are of narrow gauge railways. A narrow gauge railway is any railway with a track gauge less than 4 foot 8.5 inches, which is the standard gauge of mainline railways in many countries. Because of the narrow track gauge, the smaller overall size and the lighter weight of the locomotives and stock, these railways can be built far more cheaply than their standard gauge counterparts. Tighter curves can be used, enabling tracks to follow more closely to natural geographic contours. Smaller buildings and structures are the norm, all adding up to the rather quaint appearance for many of the well-known examples. The charm and character carries over well into the models, as do some of the construction benefits of the full-size railway. The ability to negotiate tight curves, for example, and the small, quaint-looking stations lend themselves ideally to fitting into even the smallest of gardens, while still allowing the use of prototypical length trains pulled at scale speeds. We really have two separate scales and gauges here, SM32 and G-scale, though in practice we group them together. SM32 simply stands for 16mm, referring to the scale of 16mm to the foot to which they're built, and 32 refers to the track gauge of 32mm. These then represent models of 2-foot gauge equipment, and are often referred to simply as 16mm or 16mm narrow gauge. You'll also come across SM45, which similarly translates into 16mm to 1 foot, running on 45mm gauge track. G-scale models are built to approximately 14mm to 1 foot and run on 45mm gauge track, and represent metre gauge railways. The slight difference in scale between G and SM32 is offset by the fact that most G-scale models are of American or continental equipment, which are generally larger than the British stock modelled in 16mm scale. To illustrate this, the engine on the left is SM32, or 16mm to the foot scale, and the one on the right, G-scale, or 14mm to the foot. As you can see, the overall size is the same, and the only obvious difference is the track gauge. As a general rule, anything referred to as G-scale, SM32, SM45, or simply 16mm will all be size compatible. We've previously mentioned the track gauges of either 32 or 45mm, but don't confuse these with O gauge and gauge 1. Although SM32 shares the same track width as O gauge, and G and SM45 have the same track width as gauge 1, there's no other similarity. As both O and 1 gauge represent standard gauge, as can be seen on this gauge 1 railway, they're both built to much smaller scales than our models, and even track standards are different. Roundhouse locomotives are all capable of having their wheel gauge altered between 32 and 45 mm, so they can run on either gauge. Driving wheels are locked in place on their axles by small socket screws and are simply moved from one gauge to the other using a small key and special gauge. A conversion kit is used for pony trucks and tenders. Roundhouse have been producing steam locomotives since 1982 and are now the major manufacturer of this type of model in the UK. Our reputation for reliable and hard-working models is well known worldwide. Originally, only simple spirit-fired locomotives with slip-eccentric valve gear and tin plate bodies were produced, the first model being Victoria. As the market developed, models became more sophisticated. Slip-eccentric valve gear was joined by Hackworth, then a simplified Walschaerts, and firing changed from spirit to internal gas due to its ease of use. Radio control in the early days was very much an optional extra, whereas today it's rare that a manually controlled engine leaves the factory. In the mid-80s, Roundhouse purchased the Beck steam locomotive range, originally manufactured in Germany, and produced these for several years. Development of new products and refinement of existing parts and systems is an ongoing thing. At Roundhouse, we don't believe in change for change's sake, and if an item works well, it can become a standard part on many different engines. But we always have an eye open for improvements. Two recent cases, both brought about in part by EC directives, have been improvements to certain AM radio equipment to overcome EMC problems, and the development of the Roundhouse FG type gas burner for increased efficiency. Both involved testing and development in our own workshops, together with the expertise and laboratory facilities of Leeds and York universities. For some years, Roundhouse was operated from workshops just a few hundred yards from the famous Doncaster Plant Works, birthplace of many of the Great Northern and LNER locomotives, but moved into the Wheatley factory in 1990. Though not all parts are manufactured in-house, everything from administration to final testing of models is carried on here. A small showroom and test track are also incorporated, and customers are always welcome to come and visit. For those who like to see firsthand just what goes on behind the scenes, our annual open day is always a popular event. So much for the background. Now let's take a brief look at how Roundhouse locomotives are actually manufactured. Starting at the beginning, initial design work is carried out using Computer-Aided Design System, or CAD for short, and where necessary, reference is made to drawings and photographs of actual engines. Complicated designs can be quickly built up and checked before anything is made, and movement of parts can be simulated to make sure that everything is in its correct place. Multi-layer drawings are built up to make design easier, and standard parts can be imported into drawings in seconds. Individual items, like this expansion link, which is laser cut from stainless steel, can be isolated and dimensioned. Conventional drawings can be quickly and accurately produced by means of a plotter. Once a design is finalized, frames and motion parts are laser cut and brass bodywork photo-etched from the drawings produced by the computer. Of course, there's still a place for the traditional skills of the graphic illustrator for producing brochure and operating manual illustrations. All locomotives are produced in batches. In this way, quantities of similar parts and sub-assemblies can be made more efficiently to speed up overall production. Bodywork, previously produced by photo etching from the computer-generated artwork, is formed to shape and assembled by a mixture of electric resistance welding and soft soldering. Some extra detail parts for the locos, along with a small range of line-side accessories, are made in-house by the centrifugal casting of white metal. Brass casting, formed by lost wax or investment method, are also used, but are not produced in our own workshops. After assembly, the brass bodies and panels are cleaned by high-pressure blasting, then racked, ready for painting. To cope with the rough and tumble of garden railway life, and to stand the relatively high temperatures that certain parts reach, a modern synthetic paint finish is used. First, a special etch primer is applied to the newly cleaned parts. Then a double coat of colour goes on top to finish. All painted parts, including chassis etc., are sprayed in colour batches. Then, after curing, finished items are stacked ready for assembly. Basic machine parts are taken care of by an automatic capstan lathe. Every action on the machine can be controlled and timed individually, so that quite complex items can be produced with the minimum of human assistance. All the normal operations such as drilling, tapping, threading, knurling and even cross-drilling at 90 degrees can be programmed to happen in sequence. This enables one machine to make a wide variety of parts, from these brass boiler plugs to stainless axles. The production of parts and assemblies is constantly going on in the background, so that loco assemblers have all the parts to hand when they start the next batch of models. Stage 1 of assembly begins with the basic chassis. Using a mixture of laser cut and machined parts, a working unit is carefully assembled and the valve timing set. After a quick test on air, all chassis are run on steam on a purpose-built test rig for about 8 hours. This ensures that all moving parts bed in together, resulting in a smooth-running chassis before anything else is fitted. Once passed OK by the inspector, the chassis passes on to the next stage where the boiler and all its associated parts are fitted. Many of the gas and steam fittings are polished as they're fitted, and great care is taken with routing pipework and sealing joints and ensuring that the gas system is operating correctly. At this point, a first steam test as a prime mover is undertaken. This takes about half an hour and incorporates checking of the gas system, checking for any steam leaks, haulage capabilities and any final adjustments to the valve timing. Only after a successful negotiation of this first test run will a model be passed on to the finishing stage where the body and all other items are fitted. This isn't the end of the story, however, as a further half-hour test has to be endured and passed by the finished loco before the engine is finally placed on the ready-to-go shelf or packed up ready for collection or dispatch. Every engine is supplied complete with a basic toolkit, full operating instructions and a 12-month guarantee, and our careful assembly and thorough testing procedures ensure excellent running straight out of the box. How easy is it to operate a typical roundhouse engine? Let's run the procedure with this William loco and show you. Your main requirements are water, fuel and oil. Water first. The filler plug is removed and the boiler filled completely with clean water. A syringe and tube are included in your toolkit. Insert the tube again and withdraw 30 ml of water to give an airspace, then replace the filler plug and dome. To get to the fuel tank, we simply lift up the roof. The fuel used is butane and the tank on the loco is filled from a canister in about 30 seconds. Lighting is simply holding a light over the chimney and turning on the gas valve. While the burner warms up, we can see to the oiling. Inner cylinder lubrication is taken care of by a displacement lubricator. Remove the filler cap, remove the drain screw and let any water out, then replace the drain screw and fill up with the special oil before replacing the cap. External oiling, which includes all the valve gear, axle bushes and any other moving parts, can be done with ordinary machine or motor oil. Normal working pressure is 40 psi and that's raised in about 5 minutes. A pressure gauge is fitted so you can monitor progress, but the lifting of the safety valve tells us when it's ready. This loco's radio controlled, so we can now switch on the transmitter and receiver and we're ready to go. First select full gear for the required direction by moving the right hand transmitter lever, then slowly open the regulator with the left hand lever till the engine moves off. The rate at which steam is produced is controlled by the gas regulator, so if we have a heavy train, the burner can be turned up to give more available steam. Most of the models operate on the single fill system. This means that you fill up the boiler, gas tank and lubricator and run the engine till the gas tank is empty. This gives around 25 to 35 minutes of operating time. The procedure can then be repeated again as often as required. The current exception to this is the Sandy River number 24, which has a water tank and pump in the tender and a water level gauge in the cab to allow the boiler to be kept full indefinitely. Layout of controls and positioning of gas tanks and boiler filling plugs varies from engine to engine, but most engines feature a hinge-up roof to make servicing easier. There you have it. No fuss, no complications, just a simple procedure to follow each time you steam up. As well as ready-to-run locomotives, Roundhouse also make a large selection of individual parts for the home builder who prefers to do his own constructing. This coal-fired version of the Sandy River number 24, built by Shaw Steam Services Limited, uses many standard Roundhouse parts. So does this fine saddle tank, and even the impressive 262 piloting one of our own number 24s on this double-headed special. Our home builder range allows you to use tried, tested and reliable parts in your own designs. The Roundhouse range of models changes from time to time as new models are introduced and old ones phased out. We've already shown you some of the early models and some in production at the time of filming, but please check the current brochure to see exactly what is available now. One thing never changes, however. Whatever model you decide on, If it's roundhouse built, it'll give you years of good, reliable service. Now sit back a while and relax while we finish off with a selection of roundhouse locomotives, both past and present, doing what they like best, raising steam.